Hello everyone, my name is Shuhan Zhang, and now I will introduce the method that I use to solve the question 10 in homework 8. The question 10 want us to show that if the normal process is y-sense stationary and and then it is a strict size stationary. So first, if we want to prove the normal process is strict size stationary, we need to show that the probability density functions of x1 to xn and from t1 to tn should equals to the density functions of t1 to x1 to xn and from t1 plus epsilon to the tn plus epsilon, which for any in that equations for any n and any t1 to tn and any epsilon. So first, let's write the probability density functions of normal process, which is like this, because each x is uh, independent identical distribution, so we can write the functions like this. And x is a matrix, is a line matrix, is a row matrix. Sorry, it's a column. Is a one time n column, which is which is n time one column from x1 to xn, and C is a correlation autocorrelation matrix of each x from x1 to xn. And we can write the autocorrelation in definition. And the first part is uh, xt1 minus the expectation of xt1, since the normal distribution is y-sense stationary, so the uh, expectation of x1 should equals to eta, and for every x the expectation should also equals to eta, and we can write the transpose of x minus eta like this. So we multiply the two matrix and get the autocorrelation matrix, which is like this. And we can simplify this the autocorrelation, because it's a WSS distribution, and autocorrelation only cares about the difference of two input. And then, since the probability density functions is a matrix of each difference, so we can rewrite the C like this, which each input equals to t1 minus t2, t1 minus t3, and so on until to the tn minus 1 minus tn. So we can simplify C equals to ti minus tj, which I not equals to j, but I and j equals to 1 to and I and j are range from 1 to n, and they are integers. So now let's prove the SSS distribution. Sorry, SSS probabilities. So first, let's write the jointly distribution functions of normal distribution, which is like this, and then we can rewrite the last part based on the calculation above. So we have these equations, and then we need to prove the property of SSS. Then we add epsilon to each t. Since we have these properties and we apply epsilon to the Ti and Tj, and finally we get the probability functions also equals to the x1 to xn and t equals to ti to tj, and I not equals j, and I and j range from 1 to n. So we have the same explanation as we defined. So the density functions when t plus same values equals to the probability functions at t naught plus any values. So we prove that the normal distribution, when the normal distribution is WSS, and then the normal distribution is also satisfy the definition of SSS. So that's all. Thank you.